Hi, nice to have you in today's discussion. We are going to be looking at a topic called chemical equation. It is a very important topic in the study of chemistry because students in most cases find it difficult to write simple chemical equations, and they also find it difficult to balance equations. Balancing of equation has always been a big problem in the lives of students, as they find it difficult to understand some of the basic steps or some of the basic principles used to balance chemical equation. In the course of this class, we are going to be looking at some examples of chemical equations and how to balance chemical equation. So I strongly believe that if you are in this class, then you should count yourself lucky, because it will be a simple task to you when you come across any kind of equation, and you should be able to balance all kinds of chemical equations in chemistry. So I want to urge you to sit tight and follow the steps on how to write chemical equation, balance chemical equation, and even solve calculations in chemical equations. Now, for the sake of this class, we're going to be looking at what a chemical equation is all about. A chemical equation is simply a chemical reaction represented in paper form in the form of chemical symbols and formula. It is simple, is it not? Now, the definition says a chemical equation is written in paper form in the form of chemical symbols and formula. Now, a chemical equation can be written in a simple form as follows. So we can have A plus B to give us C plus D. Okay, so this can be a simple representation of a chemical equation. So here we have our A and B as our reactants, while the C and D are products. Now A here represents a reactant, and it is written at the left hand side, and B also is a reactant, and it's also written at the left hand side. Now if you take a look at this equation, the reactants and the products are being separated by a sign known as the arrow sign. Now this indicates the boundary in which, or the process in which, the reactants have to undergo to form the products. So the products are written at the right hand side, while the reactants are written by the left hand side. Now, taking a look at this equation, you can also have other coefficient or numerical coefficient that can represent number of moles in a chemical equation. So we can simply represent that with small letter A, small letter B, small letter C, and small letter D. This can simply represent the numerical coefficient in a chemical equation. So these small letter A, B, C, and D can represent numbers, numerical numbers. That is numerical. They must be whole numbers in a chemical equation. So this is a general form in which a chemical equation is represented. Now, just as we rightfully said, it is involving chemical symbol and formula. So A here can represent a particular element, B can represent a particular element or a compound, C and D also can be either a symbol of an element or the formula of a compound. Now, a chemical equation can also be written with double arrows or represented with double arrows, which indicate reversible reaction. So reversible reactions are reactions that can be made to proceed on either side, that the reactants can combine together to form products, and the products also can, in a backward way, combine together to form reactants. Okay, so such reactions are called reversible reactions. In most cases, there are conditions that leads to reversible processes, such as change in temperature, concentration, pressure, and other factors. So, but we are not talking about reversible reactions for the sake of this class. We are simply concentrating on what a chemical equation is all about. Now, other ways that a chemical equation can be represented in paper form, let's take a look at a common example of a chemical equation involving sodium as an element and chlorine. will give us sodium chloride. Okay, so sodium reacting with chlorine will give us sodium chloride. This is a common example of a chemical equation. So chemical equation can be represented, or the reaction between sodium and chlorine can be represented using this simple equation. Now, if you take a look at the equation, there are letters that are written in subscript representing the physical state of the reactants and the product. It is very important that we indicate the physical state in which the reactant and the products occur in writing a chemical equation. Now, trying to write a balanced chemical equation, it is very important that we understand the concept of stoichiometry. What then is stoichiometry? Stoichiometry simply means the relationship or the study of the quantitative relationship between the reactants and product in terms of number of moles and atoms. Of course, a chemical equation must have number of moles of both reactants and product. So in writing a balanced chemical equation, we must indicate the actual number of moles of the reactants and the product, and that is what we call stoichiometry of a reaction. We will not be going into details on stoichiometry of a reaction. We shall be calling it a day for today's class. Hope to see you in our next class, where we are going to look at how to balance simple chemical equations, and further we'll also look at some calculations in chemical equations. I hope to see you in that class, where more about chemical equations will be explained.